Hello and welcome to today's lesson. So we are going to get into some radical math. So this is going to be a review and build on hopefully some of the stuff that you did last year in your algebra course. So we're going to be talking about radicals. All right, so this symbol, this red symbol right here, is called your radical symbol, and the number underneath is called the radicand. So this is read the square root of 25. Okay, so how do you read this? There are actually three different ways that you can read this, and one is just saying radical 25, or the way I just said it, square root of 25, or some people just say root 25. And what does that mean? It means what number times itself will give you 25. So 5 times 5 is 25. So the square root of 25 is 5. Now we just have to be a little bit different. Sometimes we do x squared equals 25. What number squared is 25? So now we're taking the square root of both sides. And in this case, we would say a plus and a minus 5 because negative 5 times negative 5 also gives you 25. When it is just written like this, the square root of 25, they are always looking for the principal square root, and the principal square root is always the positive root. So we would just say 5. All right, perfect squares. What are perfect squares? So when you take a number times itself, then you're going to get a perfect square. So a square root of a numbers that have integer square roots. Note that square roots of numbers that are not perfect squares are irrational. So here are your perfect squares, because 1 times 1 gives you 1, 2 times 2 gives you 4, 3 times 3 gives you 9, 4 times 4. So these are all of your perfect squares. The non-perfect squares are these numbers in between here. So do you see how we're missing 37, 38, 39, and so on? So the square root of 37 is an irrational number because it does not come out to be a nice perfect square root. So the square root of 100 is 10. So 100 is a perfect square, 37 is not. All right, so I'd like for you to just take some time, pause this video right now, and then go ahead and do these square roots. All right, let me move the worksheet up a little bit for you. So just do the ones that you can see here. So stop the video, pause it, and when you come back, you can correct this and see how you did. Before you turn your video off, you should probably come back and we should probably go through a couple problems so that you can actually do some of the ones that are not perfect squares. So we are going to simplify the square root of 8. And how we're going to simplify the square root of 8 is we are looking for perfect squares in 8. So if I take the square root of 4 times the square root of 2, 4 times 2 is 8. 4 is a perfect square, and the square root of 4 is 2, so we're left with 2 root 2. All right, let's try another one, 24. So you guys can do this a couple different ways, and one way is some people look at this and they say, well, that is 8 times 3. But notice 8 and 3, neither one of those are perfect squares. So you always want to pick factors that are going to give you perfect squares, or you're going to create more work for yourself. So 4 is a perfect square that goes into 24, and the square root of 4 is 2, and the square root of 6 is not simplified, so we leave it 2 root 6. Now, if you did choose it to do it this way and do 8 times 3, and you're like, oh, none of those are perfect squares, you can now say the square root of 4, square root of 2, and the square root of 3, because 4 times 2 gives you 8, and the square root of 4 is 2, and 2 times 3 is 6. So you can get there, it's just going to take you with a little bit extra work. Okay, so now we're going to go back to this, and you go ahead and stop, and then come back and correct your worksheet. All right, here is the worksheet all completed with the answers. So go ahead and just pause this video so that you can go ahead and get this corrected. I tried to write my work underneath things that just weren't perfect squares in here to help you guys out. All right, so we did that screen, and all right. Another thing to know here, just to pay attention to, is what is the square root of 3 times the square root of 3? Well, that's the same thing as saying the square root of 9, and what is the square root of 9? 3. All right, so square root of 7 times the square root of 7 is the same thing as the square root of 49, and the square root of 49 is 7. Okay, do you notice anything that's happening here? The square root of 3 times the square root of 3 is 3. The square root of 7 times the square root of 7 is 7. So without doing this step in the middle, what is the square root of 11 times the square root of 11 is 11. All right, so simplest radical form. So to be in simplest radical form, you cannot have any square roots in the denominator. So you could have something like the square root of 2 over 3. So you can have the square root in the top, but not in the bottom. Okay, the radicand has no fractions. So if you have the square root of 1 over 4, this is not simplified. So we'd have to split this up in the square root of 1 and the square root of 4. So we split this up as 1 over 2. The radicand has no perfect squares left in it. So if you have the square root of 8 over 3, this radicand 8 has a perfect square in it. So we would have to split this up into 2 root 2 over 3. So you can't have any radicals, perfect squares in the radicand. You can't have any square roots in the denominator, and you can't have any fractions. It's got to be able to be simplified to do that. Alrighty, so let's try and put these rules in place. Okay, they want us to find the area of this figure. So the area of this figure is going to be 2 root 27 times 3 root 48. Okay, the perimeter, you can do this a couple different ways. So 2 root 27, and then we have 2 of them. So you could just multiply by 2, and then add 3 root 48, and then we have 2 of them. Another way is to just write all of them out, and then they want us to do the ratio of the length to the width. So I think my next 3 screens split this up. Okay, so area. Multiplying these together. Now, there's more than one way to do these, so just know that the way I do it is not necessarily the only way. 2 times 3 is 6. I'm going to multiply those together. Now the square root of 27 can be broken down into the square root of 9 and the square root of 3. The square root of 48, isn't 48 divided by 16, isn't that 3? So we have the square root of 16 and the square root of 3. All right, so we still have this 6. Now the square root of 9 is 3, and these are multiplied together, and the square root of 16 is 4. Now, on that last one, we just said if the square root of 3 times the square root of 3 is 3. So now we just need to multiply all of that together. 6 times 3 times 3 times 4. And I got 216 and whatever that units, that label was, squared, because we're finding area. All right. In the next one, we want to find perimeter. So in order to add things, we need to have like terms. So the square root of 27 gets broken down into the square root of 3 and the square root of 9. So we have 3 root 3. So we have 6. 2 times 3 is 6 root 3. Okay, and then obviously we're going to have another one because that's the same exact thing. And then 48 we know is 16 times 3. The square root of 16 is 4. And now 4 times 3 is 12. And then we still have our root 3. And this one's going to also be the same. So now, like terms, square root of 3, square root of 3, square root of 3, square root of 3. Those are all of our like terms. So I keep my square root of 3 and I add my coefficients. So 12 plus 12 plus 6 plus 6, and I get 36 root 3, and this is perimeter, so it is just units. All right, now they want us to do the ratio of the length times the width. So we already know that this 3 root 48 is 12 root 3. We've already done this one a couple times, 12 root 3. And we know that this is 9 and 3, so we end up with 6 root 3. All right, so now we're going to simplify. Well, root 3 over root 3 simplifies to 1, and 12 divided by 6 is 2. So this ratio is going to be 2 to 1. All right, the last thing that we need to talk about here is going to be to rationalize the denominator. So mathematicians say we are not allowed to have a square root on the bottom. So I am going to multiply by a number here that is going to be a fancy 1, because if I multiply by 1, I don't change the value. So my fancy 1 that I'm going to multiply by is the square root of 3 over the square root of 3. Why do I want that? Well, because we just found out earlier when we take square root of 3 times the square root of 3, we get just 3. And so what happened is our radical is now gone. And so on the top, we have 21 root 3. And then we always have to simplify. So 21 divided by 3 is 7. So this is 7 root 3. Okay, this is called rationalizing the denominator. All right, so this first one, I would just grab my calculator and say second square root 4356, and this answer is 66. All right, the first thing I'm going to do here is 8 plus 1 is 9, so I know 3 goes in there. So 108 divided by 3. So I have the square root of 108 divided by 3. Well, 108 divided by 3 is 36. And now the square root of 36 is 6. All right, this one is the square root of 9 over the 4. So if we look at this individually, the square root of 49 is 7. And on the bottom, we have the square root of 4, which is 2. So sometimes you want to put them back together under the radical, and sometimes you want to split them up depending on the kind of problem you have. All right, so this I think is going to be our last problem. So why is this not simplified? Because it has a square root in the bottom. So what we're going to do is rationalize the denominator. I'm going to multiply by my fancy 1. So I'm going to multiply by the square root of 5. So on the top I have 20, and then 7 times 5 is 35. And on the bottom, the square root of 5 times the square root of 5 is 5. Now there are no perfect squares in the square root of 35, so that can't simplify at all. Sometimes it does, but 20 divided by 5 is 4, so this is 4 root 35. All right, so now you should have a worksheet in there for you to work and simplify your radicals. Good luck on your homework.